Hi, Fred B here, and in this video I'm going to be presenting a visual overview of the first amplifier I designed and built. Let me get the cord out of the way here. Okay, this is a 2-channel. It was originally intended to be 50-watt amplifier, but since I got the output transformer with a 6K6 primary impedance, it turned out to be about 35 watts output with the supply voltage I have on this amplifier of about 425 volts. Alrighty, let's see. On the front panel here, we have the input, of course, and we have channel indicators. Blue is clean and red is distortion channel. The clean channel is channel 1 here. They have separate tone stacks. So we have low, mid, high, and a channel level. On the second channel, we have a selectable gain. This is a negative, this controls in and out of a negative, local negative feedback loop on the first distortion gain stage. Without the negative feedback loop here, the second channel already has some distortion even at the lowest gain level. So with the negative feedback loop, it will clean up all the way to absolutely clean and then to a fairly distorted bluesy type of tone. And then when you take the negative feedback loop out of the circuit, it goes from low moderate distortion to saturation. And again, we have the low, mid, and high. And these tone stacks are high impedance tone stacks. They're sort of like Fender tone stacks. There's no cathode follower before the tone stack. So they have a general, they're a middle of the road tone control. Okay, and then to finish out the front panel here, we have the distortion channel level control. We have FX loop. Now the FX loop is switchable, again with a push-pull switch for series and parallel. It's a tube buffered FX loop. These two tubes are the gain stages for the preamp. This tube is the send and receive buffer for the FX loop. And this tube is the phase inverter. 12AX7, we started. These are two 12AX7s. This is a 12AU7, and this is another 12AX7. At the moment, I have JJs in for the preamp stages. This is a Chinese 12AU7, and this is a Ruby 12AX7. The power tubes at the moment are big bottle 6CA7s. Okay, now let's on some good stuff here. We have our usual normal presence control and a level control, which is the master volume. This master volume at the moment is set up as a post phase inverter master volume. It's a dual pot and one pot on each phase before it goes into the power tubes. Then we have some neat stuff here. This is a body control. Now this is a pot on one of the phases of the phase inverter, and it will turn it from 100% down to 0. So you have control. You can control how much second harmonic is included into the power amp from the phase inverter. It takes the vibrance out of the tone and makes it sound a little old and dry with you don't turn it all the way down, but you can take the edge off the tone and make it sound like a vintage amp. With it all the way up, with it perfectly balanced, it sounds very bright and very juicy is a good word for it. Okay, now then this preamp that I built is based upon Kevin O'Connor's London Power Standard preamp. So there's 4 gain stages, and the middle 2 stages switch in and out. That's the second channel. and each channel has its separate tone stack. And in addition to this, I used to put the power scaling in this circuit, in this amp. So we have a power amp supply voltage control. This is the normal power scaling control. And I also included the electronic sag control, which I like even better than the power scaling. Again, this kind of makes, with the sag set on 0, this is a very big, overly sufficient power transformer for this amplifier. So with the sag control set to 0, this amp is very punchy, very crisp, very bright. And then as you turn the sag down, it'll lower the supply voltage by about 200 volts at its lowest setting, but it increases the sag of the power supply as it draws more current. The power scaling, in contrast, reduces the supply voltage but maintains a low impedance from the power supply. This increases the impedance of the power supply. So it gives you additional flexibility and control from the power section. And again, it takes the edge off, makes the sound smoother, less vibrant. You just have to hear it. And I'll be doing some tone demos of this amp. Now over here we have a standby indicator and a ready indicator. Now the LED diode on this one happened to burn out. I picked a limiting diode with too little resistance to limit the current through that one diode, and that diode burned out, so I have to replace it. So we have your regular ready standby switch. Okay, to go over the top here a little bit more, this is actually a salvaged single-ended output transformer, a small one. It was like maybe 5 watts, that I put in here as a choke for the preamp. And this could be replaced with a regular Hammond choke, but this works actually fine as a choke. Don't need a whole lot of Henrys on the preamp, just enough to filter out the ripple from the power section. It's going to the power tubes. This transformer here is a auxiliary power for the switching. It's an FET switching scheme, and that supplies the power for that. Okay, power tubes and of course the output transformer. Now I'll flip this around and we'll do a back panel overview. Okay, continuing on now, we have the back panel. This is a filament transformer and it's only 4 amps. I put it in here to separate the filament transformer from the main power supply transformer, the main power transformer, in an effort to reduce hum and noise in the amp. And it's okay. I didn't really notice a whole lot of noise reduction, and the tubes, the 6 tubes in this amp actually draw about 4.2 amps. And this transformer runs a little hot. It's only rated for 4 amps. The main power transformer will supply 5 amps at 6.3 volts, so I'm going to take this out and put the heater filaments back on the main power transformer. Okay, we have input module with a common mode choke in there and a fuse. Nice little all-in-one gizmo there. The main power switch is here too. We have 2 parallel output jacks. Have an impedance selector for 4, 8, and 16 ohms. Have the send FX loop send level control. The send jack, receive jack, and I included a pentode triode switch in this amp. I care very little for the triode mode. It sounds a little weird. It just takes the crispness off of the distortion. Perhaps I should re-bias the tubes when I put them in triode mode. That might help the sound a little bit, but I prefer pentode mode. Then we have the bias taps for the tubes and the control pots for each tube's bias current is separately adjustable. Then we have a foot pedal switch to control the channels. And without a foot pedal switch, I just use this shorted plug to control. Out is on, with the plug out, it's on the amp runs on the clean channel, and if you put the plug in, which shorts the contacts, that runs the distortion channel. And lastly, we have a ground lift, which I always keep it on because if you lift the ground, the amp gets quite noisy in all situations that I've used it. So there you go. All right. Next, I'll go the guts overview. I'll give an overview of the guts inside and the boards that I created for the amp. Alrighty, here we are looking at the guts side of the amplifier. And when I was designing this amplifier, I had some conversations with Kevin O'Connor because I was basically following his preamp design and power scaling and channel switching scheme for the London Power Standard preamp. And one of the things he said was, more boards is good. You should have a separate board for the power supply, a separate board for the power scaling, separate board for the output section, a separate board for the preamp section, separate board for the phase inverter, and separate board for the effects loop. More boards is a good thing. Well, back when I was putting this amp together about 5 years ago, I thought, I don't want more boards. I bought this chassis. I should have gotten the next larger chassis, which would have given me 2 more inches of room lengthwise. But I got this chassis and I said, you know what? I can hardly fit more boards in there. And I had trouble seeing the utility of more boards. Well, you know what? Kevin was right. Some may say, of course he's right. But I have a need to discover things on my own. And how I figured out that he was right on this was I've gone back and adjusted a lot of stuff in this amp. I put it together and I thought it would be almost done, by the first time I put it together. But I actually spent a year or two adjusting values of stuff and rewiring things. And if you have to take a board off to get underneath, it's a lot easier just to take one little board off, like if this was split in half, to get under something under here. Or, if you want to redo something, to take one little board out and fix it. So there was utility in the method of using more boards for each little section of the amp. Okay, so in this amp I should have split off a couple here, and I'll explain what each one is. This board here, of course, is the power supply board, and I have in here, I've fused everything. I've fused both sides of the high voltage output of the power transformer. I've fused one side of the heater winding. And some additional things I put in here, I put snubbers in on the high voltage rectifiers. I put an additional 1U cap right after the rectifier diodes just to help reduce the stress on the power scaling circuit. And here's some additional circuitry for I made provisions, included provisions for fixed bias voltage that I haven't used in this amp, but I included the provisions on the power supply board. So here's your off, on, your ready standby switch. Okay, so this big thing is the preamp board. Here is the input circuitry for the input stage, and then the two gain stages, the last gain stage. These little babies here are the FETs for the FET switching, which I actually had to redesign the circuit for. The circuit in the I forget which book I used, Toot 5 or Toot 3, didn't work as well as I'd like, so I redesigned the circuit, and it works better now. Absolutely quiet. The switching works beautifully. And I built a lot of the components for the tone stacks directly on the tone stacks. I originally put the amp together without all of the shielded wide cabling, and it squealed like a pig being slaughtered, brought to slaughter. So I had to go back and redo everything with shielded cable, and now it's much more well behaved. If you ever look inside a Dumble amplifier with all the close wiring like this has, there's lots and lots of shielded cable in the Dumbles. Okay, so now this section of this board is the power scaling components. There's a large MOSFET mounted to the top of the chassis behind this little hole here. Then from here on, this is the power section, output section. And this was another interesting thing that Kevin O'Connor includes, is the use of multiple capacitors and making provisions so you can put in multiple capacitors, so you can make it very modular. This amp now has 88 UF on the plates of the power tubes, and you can take these out and mix and match and put some 10Us in there. So if you wanted to put a smaller amount of reservoir capacitance on the plates of the power tubes, you can do that. You know, it's very adjustable this way. I got 22 UF on the grids of the power tubes. Here are my bypass caps for the cathode bias, and I forget what they are. I think they're only 200U, 220U. So there you have the gut shot of my first design amplifier based on the London Power standard. Now I included all of this was actually a little overly ambitious for my first design, although I missed that fact when I was laying this out. I wanted to include all of the features like the FX loop, the power scaling with the sag control, adjustable bias. This is pretty standard, that wasn't anything added. You know, so I could have a useful amp that I could take out and go and play immediately. 2 channels was an absolute necessity. And, you know, although it took me years of going back and readjusting it to get it working well, I think I should have probably picked a simpler, you know, built a JMP or a 5E3. My next amp is a 5E3 design. I spent quite a while designing. But this came out well. And I'll do another one of these. I'll make it a little bigger. I may go to a PC board just to help reduce the size of these boards. But, okay, there we go. Next up will be some tone demos showing the versatility of this amplifier. Alrighty, I thought I'd just give a little more about the structure of the amplifier. And in this image, you can see how the preamp is structured with the 4 gain stages. and two of them are switchable in and out for the difference between the clean and the distortion channel. Then the overall structure of the amplifier is like this, with the preamp feeding into the FX loop, which is switchable for parallel or series, then going into the phase inverter, and then going into the power section. Now, with the master volume set as a post-phase inverter master volume, the master volume is actually between the phase inverter and the power section. A regular master volume would be between the FX loop and the phase inverter. Alrighty. An interesting note here that I actually took a long time to realize was that in this scheme I have a negative feedback loop on the power section, and the post phase inverter master volume is actually inside the negative feedback loop for the power section. And when either channel is turned way up with the master volume turned way down, so that the phase inverter ends up getting overdriven, the distortion from the amp in the post master volume configuration is very sharp. There's a very hard edge distortion, and I thought for the longest time that was just the phase inverter distorting, until I realized, embarrassingly long after, that the distortion is probably so sharp because it's the negative feedback loop for the power section is working on that, creating a very choppy distortion. So eventually this amp will be returned to the pre-phase inverter master volume.